Okay, so now we looked at some physical adaptations like buoyancy, surface volume, surface area to volume, streamlining the body, etc. But they're also living in the water, and the body temperature, body oxygen, body salinity, and the marine environment also play a role in evolution and adaptation to live within the ocean, right? So cold and warm water species we already talked about a little bit. Floating organisms are smaller in warmer waters because the viscosity is lower, buoyancy is lower. They need more appendages, as we saw an example already. We'll see again. But also the metabolic reactions, metabolic rates are temperature dependent. There are equations like Van 't Hoff Arrhenius equation and so on. So temperatures favor faster metabolic rates. Higher temperatures favor faster metabolic rates. So tropical organisms have faster metabolic rates. They tend to grow faster, and they tend to live shorter lifespans, and they reproduce more often. Their sexual maturity is reached earlier. So the cold water species grow slower, metabolic rates are slower, they can get bigger, they don't reproduce as much, and so on and so forth. And of course, biomass is higher in upwelling regions. Remember, we defined upwelling where you push the water away from the coast or away from the equator and you bring up cold, nutrient rich water, which can be lower in oxygen. So upwelling can favor nutrient supply, photosynthesis, and biomass. But temperature and salinity affect marine organisms by forcing them to adapt to a certain region. So we are talking about two things. We will see that maybe marine organisms affect their environment, but maybe they have evolved to live in a certain environment. So these are arguments that go on. Nonetheless, if you look at organisms that withstand very small variation in temperature, they are called stenothermal organisms. They typically live in the open ocean because the temperature doesn't change so much, doesn't change very fast anyways. And there are those who are adapted to a larger temperature variability. They're called eurythermal. You can imagine immediately that there is also going to be a salinity related adaptation. So these are organisms that can withstand larger variation of temperature. So they can live in coastal waters where, as we saw, the temperature range is quite a bit larger than in the open ocean, 34 versus 42 or whatever, right? So salinity, stenohaline, means they are adapted to a much smaller range of salt variation in the water, so also live typically in the open ocean. Euryhaline, they live in coastal waters and estuaries where we said there are seasonal variations because of changes in the runoff that comes into the water. Rivers have a seasonality, snow melt, rainfall, etc. Or they have wind-driven evaporation and so on. So euryhaline, stenothermal, eurythermal. The big adaptation required is to deal with the balance of osmotic pressure between the water in which they live and their body water. So two things happen. When you have concentration gradients in a fluid, like here you have initial state, let's say you're trying to dissolve salt or sugar. If you just put it in and don't stir it with a spoon, you will see that it'll just sit at the bottom first if it's heavy and sinks, and then slowly it'll start disappearing because of these random molecular processes, collisions. Something called diffusion happens. You can see the animation here. I don't know if this this animation worked or not. Let's see. Yes, it works. So it starts here and then diffuses out, and this one starts here and then diffuses out. This is a slow process. It's dependent on the gradient of the dissolved substance or the substance that is in the water. So the final state is that it's all distributed evenly throughout. So diffusion is important because we are constantly diffusing in and out. We are sweat, for example, we are losing minerals with the sweat, so body diffuses out the water which is evaporated away and cools the body when it's hot and humid. This is critical because as humidity increases with global warming, at some point body's ability to lose heat may become greatly reduced and body may not be able to adapt. Okay, so those things matter for all life forms, but in the ocean, diffusion is a critical process for absorbing oxygen, nutrients. Remember, with surface area to volume, we talked about oxygen diffusion efficiency with larger surface area compared to volume, right? Same thing happens for nutrients and diffusing out the waste. Okay, so I'll do osmosis in the next podcast, but remember eurythermal, stenothermal, euryhaline, stenohaline, and diffusion across cell walls. Next comes osmosis, which relates to the concentration difference across the cell wall. Cell wall is a semi-permeable membrane. Semi-permeable membranes allow movement of water molecules but not the dissolved material. That is an important adaptation in the marine environment, also in the freshwater environment. Okay, so we'll look at that in the next podcast.